So the war for the future actually began in the past. I know that's a little strange, right? So I couldn't think of a way to create a linear story about something that hasn't happened yet. And I realized that wasn't even correct, that we really had to go backwards in order to go forwards. I was actually born in Chicago during the analog era. I just look good for my age. I brought a version of myself from then. Salvador, would you come up here for a minute? You can stand right here. This is exactly what I looked like then. And almost exactly what I was like. By the way, after my talk today, Salvador has volunteered to do something wonderful for people who are interested. Salva, what are you going to do?
Make it autographed.
Of what?
Of a robot that I'm going to make in the future.
Cool, thank you. Okay, you can have a seat. You can use this pad when people ask you. I did not coach him. In fact, I couldn't keep him from coming with me today. As soon as he found out this was something about the future, he wanted to be part of it. Okay, go sit down now, please. So, back in my day, it's when there were still islands of information. When the world could still be described in this linear way. But that's not true anymore, is it? But I was actually born when you called it futurism, not retrofuturism. I know, and what's the difference? Well, retrofuturism is the future is seen from the past, and the past as seen from the future. That sounds awfully non-linear, doesn't it? And what I'm talking about now is something we might call atemporality. The end of history, not the Francis Fukuyama kind. The kind where everything's all organized and neat and tidy and everyone stays in their box. No. No, I'm really talking about the kind of atemporality that maybe is best emblematic of remix culture, of grabbing and taking pieces of things that people did not expect to be used and recombining them into different ways. That's really what I mean by atemporality. And it's a term that was coined by Bruce Sterling and William Gibson as a way of describing the strange sense of no longer having a clear direction for the arc of one's life. That instead, there are multiple arcs going on simultaneously. And how do they converge? Perhaps they don't. Anyway, back to my story. So I was born in the analog era, and my first computer was actually an analog computer. It was made from relays and capacitors and resistors, and you programmed it using punch cables. I was able to write my first piece of software, which was a logic game that went something like this. You have a farmer, he has some grain. He has a chicken and a dog. These four are traveling along and they find a river, and they must cross this river. Unfortunately, the boat will only hold two at a time. Who knows this? Who knows this game? Okay, not everyone, but we're almost done. So the dog is vicious, the chicken is hungry, the grain defenseless. What now? The farmer has to think, how will he transport across the river without losing either the chicken or the grain? I guess he cares about the dog, so the dog's going to be all right. Well, if he puts himself and the grain in, then the dog will eat the chicken. If he puts himself and the dog in, you see how this works, right? Well, it's a trick problem. The only way to solve it is to go back across the river one direction with one of the things you'd already brought over. So this was a very, very challenging problem to solve using analog computing, or any kind of computing, if you don't think it through. And my first experience was building this analog computer from spare parts that my uncle owned a camera and electronics store, which at the time meant basically SLR cameras and the new technology digital calculators. Wow. Well, I suddenly became aware that there was this thing called digital, and it was very, very interesting to me. So I took my analog computer and I taped it to the handlebars of my bicycle, Schwinn, and I rode down to a little place there in Evanston, Illinois called the Itty Bitty Machine Company. Anybody ever heard of the Itty Bitty Machine Company? Well, that's sad. That was the first computer store on earth. And it was opened by a man named Ted Nelson, who wrote this book. He's also known as the father of hypertext. This is my Exhibit A. I will pass this around. Please be gentle. This is my original copy. So we have relics of the past. Because now in the digital era, it's too easy to erase the things that have gone before. In that sense of atemporality, we're confused to know whether things actually happened or whether we only heard about them. Well, here's a little bit of physical proof. So I rode down there on my bike with my analog computer, intending to sell it to them in exchange for a digital computer. Well, you can imagine how well that went. Ted Nelson is known as a somewhat curmudgeonly fellow. He looked at this scrappy, scruffy, really kinky, curly-haired kid with a dirty bike and a duct tape analog computer, and he said, "I'll tell you what, I'll let you list it on my bulletin board." Except at the time it was not a digital bulletin board, it was using cards just like these that were actually tacked to a bulletin board with ads for people who were looking for roommates at Northwestern University, which was located right across the street. So from that point, I realized I was going to need to make a lot better friends if I was going to make any progress in the computer industry, such as it was. Especially being a broke kid, because there were no such things as personal computers yet. The personal computer had not yet been invented. They were called microcomputers back in that day. Well, my parents divorced, my mother moved to California, and by very good fortune, I found myself near the first, I guess I would call it, collaborative workspace for children, known as the Apple Tree. And the Apple Tree was a kind of experimental laboratory opened up by Alan Kay and his friend Steve DeWitt. Steve DeWitt became very, very good friend and mentor of mine, and as a result of basically letting me hang around and not pay, because they charged an hourly fee for these Apple II computers, and of course I was one of the kids who couldn't pay. So I just hung out, and eventually they would, if somebody came in who was a paying customer, they'd kick me out. But the Apple Tree exposed me to the fact that the computing revolution had already begun, that technology was already there, that it was so compelling and so exciting, I was absolutely ready to ditch my entire high school experience to just go to this place and to connect to this thing. Well, I stayed in touch with Steve and Alan indirectly, and I managed to get involved in the Apple Advanced Technology Group as a very, very young punk kid, trying to go where I was not necessarily belonged, but where I would try to earn my place as best I could. And I was fortunate to see a pre-release of a piece of software known as HyperCard. And HyperCard was the web before the web. It was a remarkable thing. And it really excited me because with some of the ideas, oh, by the way, exhibit number 2 from the Apple Tree. Apple II Programmer Aid number 1. You can pass these back. Just make sure they don't leave. This is what we used to program. Paper. We used graph paper back in that day to program. Yes. Hard to believe, isn't it? So at the Apple Advanced Technology Group, this pre-release version of HyperCard really got me excited. And it started me thinking, probably for the first time. And I realized something, that hypertext was just one side of the coin that was knowledge. It was just a way of representing knowledge. And that inference engine, something traditionally associated with artificial intelligence, the creation of an artificial psyche, if you will, or the futile attempts at it, that really hypertext and expert systems were one side of the same coin. So I wrote a paper about it that was published in Byte magazine and got very excited about these things and created a product called HyperX. It was actually open source before open source. We just had free source code included. So I guess it was source included, not technically free and open source, since that concept had not been introduced to my tender young mind as of yet. But HyperX was an expert system written in HyperCard. And HyperCard had the ability to extend it, that you could actually connect it to external pieces of hardware. And now this was a monumental step forward. I had started, remember, soldering things together in the analog world. And all of a sudden now I had crossed a chasm that had led me back to a connection between the digital and the analog. Very, very early connection. So with HyperX, we were surprisingly successful for our day, which is nothing in the modern era. We took that software and we started doing factory automation software. It turned out that factory automation was the big new industry. Computerized pick-and-place machines. That the IBM's laptop computer, the first laptop that they ever built, was actually designed and manufactured in a factory that the quality assurance systems were monitored using HyperX and some external commands, or X commands as they were known. A very, very exciting era. But then came the end. The AI winter. In the 90s, perhaps overblown promises about what we could and could not do, combined with lack of strength in financial markets for risky investments, suddenly the hot, new, exciting companies that were doing artificial intelligence were literally gone, entirely gone, disappeared. So, what to do about this? Well, when you live in the future, it's a little confusing, isn't it? Because the stuff you've already gotten bored of, other people have never even heard of yet. It was just too soon. It was just too early. You know, if Dan and Bill, who had created HyperCard, had just thought about it as a network instead of as a file system, they would have been 10 years ahead of creating the web. But they weren't there yet. The idea here is that it's about the ideas. It's about the people. The machines are nothing more than a manifestation of our own humanity and how we express that. So, part 2, toys. So any sufficiently advanced technology starts out as a toy, right? No one takes it seriously, it's a joke. In fact, we even say this when we are exploring a new technology or a new idea or a concept. I'm playing with it. We don't say I'm working with it. We say I'm playing with it. Why is that? I think it's because it relieves the cognitive dissonance of saying, I am really bad at doing this thing, but I'm going to do it anyway. We give ourselves an out, right? Oh, I'm just playing with this, it's fine. At some point, we switch. Someone says, you still trying that? No, I stopped playing with it. Or, yeah, I'm doing something with it. Right? It's a big switch. But I think that we don't take toys seriously. I think we look at toys and we think of them as toys. And that's a good thing. Because if you really want to know what's coming into the future, go to a really, really good toy store. When I was in Seattle, I went to a really, really great toy store. And they had a kit to build a hydrogen engine. They had a home DNA experimentation kit. Not to create, to analyze, I hope. That's a different talk, right? And so the future's already here, it's just at the toy stores. And when toys are outlawed, only outlaws will have toys. So I brought with me my colleague, Adrian Zankic. She works at the Hybrid Group with me. Among many other things, we play with robotics. We play with robotics. Someday soon we may work with robotics. So, among my many mathematical journeys, I discovered something called Conway's Game of Life, which was invented while I was still just a wee babe in diapers. John Conway, while experimenting with many, many different kinds of mathematics, discovered something that John von Neumann, who is the creator of the von Neumann machine that we think of as the basis for computing, perhaps it's Turing, but von Neumann's machine could actually be created in an even simpler way using something that Conway called cellular automata. Well, we've all seen this, right? Who's seen Conway's Game of Life? Who hasn't seen Conway's Game of Life? Okay. It basically takes place on a grid of graph paper. Again, graph paper is at the heart of all creativity. If you do not own any graph paper, go get some. You don't have to stay between the lines. It's just nice to know they're there. So Conway's Game of Life is sort of like a tic-tac-toe, except each of the symbols on there follows the same simple rules. Each one follows only a single program. And from that single program, you would get emergent behavior. So if it is alone, it dies. If it has 2 to 3 other entities next to it, it lives. If it has more than 3, it dies from overpopulation. If it's already dead, if it has 2 next to it, it reincarnates. I don't know. It was the 70s. Anyway, because we play a lot with robots, and because we play a lot with ideas, we thought, wouldn't it be interesting if we took Conway's Game of Life and we simulated in the real world out here, outer space, like here? So we started playing with this idea using some toys, again, because toys are awesome. So, why don't you bring up some of our toys. So these are some Sphero robotic spheres that you can buy at Sharper Image or the Apple Store. They glow, they move, and they have an accelerometer in there so that they can detect contact. In other words, this is the minimum viable robot. It has both input and output and the ability to move itself. That's about all you need. So what we're going to do here is we are going to simulate Conway's game of life. Well, a few variations on the rules because we need to adjust for the fact that we're in physical space and not virtual space, right? So they're going to move around instead of staying in one place. So that's a big change. We still need contact, though, because as a sort of artificial life form, contact is what they need to survive. If they don't have enough contacts or collisions, then they will die. If they have enough, then they will continue. So every 3 seconds, they're going to move around. 30 seconds is how long their lifespan is normally. They will only live longer if they're able to make enough contact. See a metaphor for me? All right. So without any practice or warm-up, let's see what happens. They're green, that means they're alive. They're moving around, looking for contact, blindly. So far, so good. Everything's all nice. Oh, death. But no, there's still some alive. They're losing strength.
Is the board toroidal? Corners wrap around?
No, there's no virtuality to this. It is what you see. Whatever they collide into is what they've collided into. There's nothing else here than what you see.
Can dead ones come back?
Oh, yeah,
No, we didn't let dead ones come back. We don't want to be here all day. And I hate to kill them while they're still alive. Artificial life form or not. Oh, these are doing pretty well. I think it's because they're at an angle. They get more speed. Oh. Our population is shrinking rapidly. And they're trapped. This usually does not end well, I have seen. But as I said, I can't kill them or terminate them. It's a bad precedent. I suspect they only have about 10 seconds of life left. So don't get too fond of them. We used to do this with 10, but that was just too traumatic. What's interesting, though, is the programming is really simple. It's about 60 lines of Ruby code to do this. And yet, the phenomenon that you observe, they seem almost alive, right? Why is that? It's because you are watching. That was just not too fast.
Can they tell the difference between the wall and another one?
The end has come. How sad. Well, give it up for the Spheros. They were so cute.
Only one left alive.
So, I say welcome to the machines. I mean, take a look around now. You can buy robotic devices everywhere. There's the AR drone. Radio Shack sells microcontrollers and parts to build your own robotic equipment.
It also sells remote control motorcycles.
I have a feeling we may be stopping for one of those later. As long as we can roboticize it, I'm fine. So we see now that we've entered an era of commodity hardware, where commodity robotic electronics are everywhere. And, you know, what about the robot economics, though? When we think about the factory of the future, the joke is the factory of the future has a man, a dog, and a bunch of robots. The man is there to feed the dog. The dog is there to keep the man from touching the robots. And suddenly we've gone back to Kurt Vonnegut, to Player Piano, which I don't know if anyone here has read, but really quite prescient for its era, that he foresaw that the demoralization of the humanity when we would no longer have some meaningful, significant work to do, especially in an era where most people worked in manufacturing. This was a really significant cultural foresight to understand that the humanity is going to be lost if we don't keep that essence in there. So what about the robot economics? Because our current economic system is very much designed around a certain distribution of product to the owners of the factory and to the workers that work there. And if there are no workers that work there, what happens to the product? I'm not an economist, but I hope that someone is and will challenge the current assumptions of our economic system with the inevitability that automation is creating. Productivity is actually the enemy of the normal guy, of the normal girl, of the normal robot for that matter. So what about robot ethics? Right? Do robots even have ethics? Only the ethics that we tell them to have. So what is going to happen? Well, I don't know. And as my friend Dan Rasmus says, the best thing about being a futurist is never having to be wrong today. So actually Dan wrote a fantastic book called Listening to the Future, where he talks about some of these themes. And he does a kind of thing called scenario analysis. He works for a bunch of big companies where they pay him a lot of money for him to say the exact same thing. I don't know. But he does it in, nice thick format. So, but this scenario analysis is very interesting. Let's apply it to two axes of thought. The first one is whether the robots are going to be sentient or not. And the other is whether they're going to be friendly or not. All right, so let's begin. If the robots are not sentient and they are not friendly, you end up with the movie Brazil. In other words, basically what we have today. Nothing works. Yeah, don't try to tell me your iPhone works perfectly. I'll pull out mine and show you better. Right? So, now, if we have robot sentience, yes, but friendliness, no, then we end up with the movie Terminator. Now, personally, I don't think that's what would happen. I think the robots would just leave. Like, what's here for us? Like, this place is a mess. Let's go where there's, like, asteroids of pure iridium. So, if the robots do not become intelligent, but they are friendly, then we end up with the movie Cyborg. Just hopefully better acting. And then, if the robots do become sentient and are friendly, then we end up with Singularity. Now, these are all Hollywood-style scenarios because you're in Hollywood. So I thought it was appropriate. But we don't really know what's going to happen, do we? Because, again, going back to that idea of atemporality, the future is always in motion. The past is always in motion when it's subject to change. How will we understand our present if we cannot understand our past and our future? That is why these types of gatherings are so important. It's like a tribal myth being brought into true life today. It's an experience shared directly from human to human without any electronic interconnection. It's just like John Naisbitt said in his book Megatrends, which was also a very prescient book from the last century. He called it high tech, high touch. The more high technology that we have between us, the more touch that we need between us. And that's what we've seen with attempts like social networking, which are somewhat pitiful early attempts at this. There's no substitute yet for real life interaction with other people. And that's not something that's going to be replaced immediately. So what will happen in that future? What about those robot ethics that we talked about? Well, there was another man back then who spent a lot of time thinking about it named Isaac Asimov. And Asimov wrote down something he called his 3 laws of robotics. So I'm sure we all know them, but I'm going to read them again. Number 1, a robot may not injure a human being or, through inaction, allow a human being to come to harm. Number 2, a robot must obey the orders given to it by human beings, except where such orders will come in conflict with the first law. And then the 3rd, a robot must protect its own existence, as long as such protection does not conflict with the first or second laws. So, how's that working out so far for us, people? The robot drone wars have already begun. The list of victims from drones has been visualized with tragic consequence. A beautiful visualization of a horrible existence. But I don't think we can blame the robots. Because they're not robots. They're drones, and they're being flown by human beings. It's really the dehumanization that has occurred, turning ourselves into robots, a kind of evolution that I think we do not wish. This is the event that has occurred from the distancing, the ambiguization of the difference between us and them being separated by this electronic curtain. So I propose that we make a small change to Asimov's first law of robotics. Just a one-word change. A human may not injure a human being, or through inaction, allow a human being to come to harm. Imagine that future. Thank you.